Okay, welcome back. Today we're going to talk about functions by using tables and graphs. Okay, now the first one, what I'm going to do is I'm going to let you kind of look at this and digest it. Um, at any point during this video, you can always pause it, take a look at it to give you some time to see if you can work it out yourself, and can always come back to see my explanation as well. And you can repeat this as many times as you want. Okay, so I'm giving you some values. Now, some of us, these are some tables we've seen in the past. Some of us have seen T-charts. But anyway, so I've given you this information, X values and Y values, and I'm giving you this N of 5. So, N of 5. So, what I want you to think about is this right here. Your parentheses, if you remember back in the first section, is your X values, okay? So that means my 5 is my X. So what I'm going to do is I'll kind of shade this in for a second. I'm going to shade this very light. So that means, okay, when X is 5, what's my answer? What is my Y value? So that means we don't know what this equation yet is, but we do know if you put in 5, it gives you 1. So the answer to the first part of this is going to be 1. Okay, what about 25? Okay, I'm going to go all the way to 25 right here. 25, my answer is 5. And I'm looking at 15 right here. My answer is 3. Okay, now the hardest part that I've seen from teaching this class over the years is this number 4 and 5. Okay, because it's typical. What if you miss it? You'll look at this 5 and say, "Oh, it's 1." That's not what it's asking. Look at this right here, X value. What does X have to be to give you 5? Well, what does X have to be? So what I'm going to look at is 5 right here. Okay, now I'm going to go opposite. Here's my 5. What's my answer? It's 25. So X is 25. Same thing with, take a look at 10. Okay, what will give you 10? Well, now this one's a little bit different because you could go right here, but it's looking for patterns. Okay, looking for patterns. So if we're thinking about this for a second, we can always just look at the pattern and go, okay, I can go 7, 8, 9, 10, and just fill these in. They're going up by 5. So it's going to be 35, 40, 45, 50. Okay? So in this case, my answer would be 50. So now some of us are trying to figure out what the formula of the problem is. Okay? What's going to be that equation? Okay? Well, we need to think about what this is doing. Okay? It's going up by 5s and the y is going up by 1s. So does that mean I need to multiply by 5? Because that's what the key factor is right now. It's 5 and a 1. 5 times 5, that does not give you 1. So think about, okay, what about dividing? Well, 5 divided by 5 is 1. 10 divided by 5 is 2. Look at 30. 30 divided by 5 is 6. Look at that one right here. 50 divided by 5 is 10. So an equation could be n of x equals x over 5, because that means whatever number x is divided by 5 gives you the y value. And that holds true to all of these. Okay, let's take a look at this next one. Okay, now I've got same situation. So at any point you can pause it and then come back for the explanation. But let's look at m of 40. Okay, m of 40. So that means my t value. So I'm looking right here. My t value is 40. So what's my answer? 400. Okay, what about 70? Well, I'm going to 700. What about 55? Now, that's a trick one because we're thinking, okay, what's it going to be? It's going to be 555? I mean, so we need to think about this. Well, I'm looking right here. 55 is between 50 and 60. So my answer is 500 to 600. What is 55 is right in the middle. So what's the number in the middle of 500 and 600? Some of us right off the bat can do 550. Another way you can also do this as well is just go ahead and since you know 55 is right in the middle, you could say, okay, 600 plus 500, those are your two values. And since there's two of them, take the average, 550. Okay, now finally, what about the last one? What gives you 300? What's your t value? What is your x value? What's this in the middle? Okay, well, I'm looking right here. Okay, there's my 300. Well, t has to be 30. Has to be. Okay, now, what would be a good equation for this one? Well, let's think what it's doing. 40 to give you 400, 70 to give you 700, 55 to give you 550, and now 30 to give you 300. You can even look over at your chart too. 10 to give you 100, 20 to give you 200, and so forth. And most of us are thinking now, instead of dividing, we're going to say a formula could be you're multiplying it by 10. So think of patterns. Okay, now I'm giving you another type of table. This time the patterns are a little bit different now. Okay, so what is P of 20? Well, P of 20 means what's my M value at 20? Well, in this case, it is 3.4. So since all of these don't have the same rate or the average rate of change, but we can find the average rate of change between two values. So in the first one, I'm asking you, what is the average rate of change? Well, I'm going to put a new formula that some of us are going to recall. It's our slope formula. It's M equals, okay, it's y2 minus y1 over x2 minus x1. Okay, so what I always like doing for your x's and y's and stuff, whichever your second one is, I use for your x2s and y's too. So these are my x values and my y values. So this is going to be, so what I would do is this is x1, x2, and this is y1 and y2. And notice one thing, your x1s have to have a y1. This cannot be right here, the 2.5 cannot be y2. Now all I'm going to do is I'm going to plug in the values of my formula, and I'm going to say, okay, y2 is 3.4, subtract 2.5 over 20 minus 10. Now, since we're going to use this on our calculator, I know majority of us are, what I want you to do is always put the top in parentheses. Then you can divide by your bottom. Okay? Now, what does this give you? Well, if you subtract 3.4 and 2.5, you get 0.9. 20 subtract 10 is 10. So then what's my answer? My average rate of change in this case is going to be, a small one. This is my M value. Okay? 0.09. So what does this mean? This means between 10 and 20, it will go up, the Y value goes up 0.09. So I want you to think about how to apply this when I say, okay, what's P of 17? Because P of 17 does not go perfectly in the middle of 10 and 20. That's why we have to find this average rate of change. So I'm going to use the 10 and 20. Now my average rate of change is going to be 0.09. Now, I'm going to use M. This is going to be my formula because between 10 and 20, whatever your M is, that's what it is. And then what is your starting Y value? It's 2.5. So we can use this formula to figure out what the 17 would be. So what is 17? Well, all you would have to do is take your 17, subtract your 10, and that gives you 7. So all you have to do in this formula is put in 0.09 times 7 plus 2.5, and this will give you an answer. Okay? So your answer is going to be, if you do this correctly, it's going to be 3.13. Now let's look at P of 12. Exact same way. So push pause and you can come back to my explanation. So we're going to do the same kind of process. Is we're going to use 0.09. But now I'm going to take my 12, and since it's between 10 and 20, I'm going to subtract the smallest, give me 2. So I'm going to put 0.09 times 2. Still going to use my 2.5. And once you do this, you get 2.68. Let me make that a little bit better. It's 2.68. Okay? Now, what about when you find your average rate of change between 40 and 50? Well, you still use the same formula. So I'm looking back at my chart. You can look at your chart too. But at 40 and then at 50, if you look back at your chart, you should get 6.4 and 7.9. So let's see. I want to just go back to make sure I'm doing this right. There's my 6.4 and there's my 7.9. So I'm going to still use my slope formula. So I'm going to say, okay, this is my y2, y1. So I'm going to say 7.9, subtract 6.4. And then I'm going to use, this is my x1, or my x2, and my 40 is my x1. So I'm going to say 50, subtract 40. Remember, always put parentheses. So when you do this, you get 0.15. So how am I going to put this in relation to the 42? Well, so basically what I'm going to do is I'm going to use my slope, or my average rate of change, which is 0.15. I'm going to put in my M. And then now, what's my starting one? Well, it's the smallest value at 40, which is 6.4. So now, I'm going to take my smallest value, which is 40, subtract it from 42, and I get 2. So my answer is going to be 0.15 times 2 plus 6.4. And I come up to be, in this case, it's still going to be pretty small, but it bumps up to 6.7. Okay? Now, I've got 2 more examples, and these should go by quicker. And then I'm finished. Okay? Now, say if you have a graph, and I've got a curve here, and where does the graph reach its max? Well, the max of this graph would be here. We're going to learn this later on. This is going to be the vertex. Okay? So what I'm going to do is I'm going to kind of do a dotted line here to there, dotted line back. I'm going to give my x and y values. Okay? Now, my x value, my x runs along the bottom. My y is a vertical line, top to bottom. So my x value, in this case, I'm going to say 1, 2, 3, and it's pretty much in the middle, so I'm going to say 3.5. My y, just go, in this case, maybe it's 1, 2, 3, 4, so y is 4. Okay? Or, in other words, maybe I did 10, 20, 30, and 40 instead. So it'd be 3.5 and 40. I'm going to use a little bit different than what I originally had. Now, what is a large number at f of x is 20? So to recall, f of x is 20, that's not where you go at the bottom, okay, because that's 1, 2, 3, 4, and go all the way to 20. No, that means what value is x when it's 20? Well, in this case, what I'm going to do is I'm going to say, okay, here's my other dotted line. Well, these are not perfect, but it should be when it's 20. If you look at 1 right here, we're going to say it's 1. So it hits it at, we're going to say 1 and 6. What is the largest number? It's 6. What is the smallest number? It's 1. That means the smallest number that f of x could be 20 is 1. Okay? Now my last one is, okay, what is the max of this? So now what I'm going to say is I'm going to just go ahead and put these in. This is 1. It starts at 1, 2, 3, 4, 5. Okay? 5, 10, 15, 20. And then I want to say this is going to be 10, 20, 30, negative 10, negative 20, negative 30. So in this case, what is the max value of f of x? Okay, so what's the tallest, the biggest value? Well, in this case, and it hits it in several points, it's 30. What's the minimum? Minimum means the smallest. Look at that. The curve hits it at negative 30. Okay? Now, if you want to, you can always go back and repeat this video. Your homework assignment, for those that are taking this College Algebra 150, it's homework 2 on your WebAssign. Also, if you're looking for my next set of videos, it's going to be demonstrating on sections 1.3 and 1.4. We're going to be doing crafts, and we're also going to be doing some word problems. Thank you for listening.